Hi guys, in today's video, what we're going to look at is how to draw and how to manipulate 3D primitives in OpenGL using C++. Now, before we start, there's a few things to understand in OpenGL, and the first thing is the right-hand rule. Now, this actually seems a little counterintuitive to what axes we're normally used to, because it takes to draw the axis, how it works is that you take your right hand and you make your thumb, index finger, and middle finger point at 90 degrees to each other. As shown in the figure, right? Once you do this, you lift your hand up and you have your thumb pointing to the right side, which is the positive x-axis. Your index finger now points to the top, which is your positive y-axis, and that makes the z-axis positive towards your direction, as in coming out of the screen is the positive direction. Now, this is something that's very important that we need to remember before we move on to drawing all our primitives. So now let's look at the first primitive, which is basically a cube or a cuboid. Okay, so right now I'm using the 3D Paint application just to give you an idea of what exactly, rather where exactly each coordinate is. Now, first, what is a cube? A cube is essentially six squares put together. So one, two, then you have three and four, five, and six. Okay, so you have six squares put together to form a basic cube. Now, as I told you about the axis that we have, so this direction is the positive x-axis, this direction is the positive y-axis, and if we turn the figure like this direction coming out of the page out of the screen rather, will be a positive z-axis. Now, given these particular coordinates, we can easily figure out where exactly each of these vertices will be. This vertex over here will be given by breadth, comma height, comma length. The breadth is how much is there across the x-axis. Your height is how much across the y-axis, and your length is how much across the z-axis. Similarly, you have this particular end as minus breadth, height, and length. This end as minus breadth, minus height, and length, and this end, this vertex, as breadth, minus height, and length. Make sure that the length for these particular vertices is always positive, because this part, the front of the cube, is coming out of the screen. Similarly, we move to the back of the cube, which is again given by these vertices. Okay, so you have breadth, height, minus length, minus breadth, height, minus length, minus breadth, minus height, minus length, and breadth, minus height, minus length. So given these eight vertices, you can draw all the six sides of the cube that you want, or cuboid that you want. So suppose you want this face, then it's these 4 points, 1, 2, 3, 4. Suppose you want this top face, it's this point, this point, this point, and this point. And if you want, say, this face, then it's this point, this point, this point, and this point. And that is the basic idea that we'll be using in all our OpenGL coding, at least for the first program. So let's move to the first program, and let me just quickly show you what it does. I just start the program and it asks me for a length. So I'm going to give my length as 1, which will be the z-axis thing basically. The breadth I'm going to give is 2 and height is going to be 3, just a random number. And you can see our cube coming to life. Okay. To show the 3D-ness of it, I've also included the animation which makes it rotate and gives you a better idea of what is actually happening. But you can remove that animation and just get a static figure as well. Okay. Let me just show you the same thing where I draw a cube. So I'm going to have a length 2, breadth 2, and height 2. And there's your cube, which is rotating. So how did we do this? Let's look at the code. So the main function which draws everything is the display function, obviously. Here, let me just explain how we draw those vertices. So you remember that a cube has 6 squares, right? So that's essentially what we do. This is the first one, second one, third one, fourth one, fifth one, and your sixth face. Okay, so this draws 6 squares, and the vertices are given as I showed you in the 3D drawing. Let's look at whether this matches. So the top face is essentially this one, like the top over here. So that has the coordinates minus breadth, height, length, breadth, height, length, and breadth, height, minus length, and minus breadth, height, and minus length. Let's just look for that. So our top face, breadth, height, minus length, minus breadth, height, minus length, minus breadth height length and breadth height length as we saw in that image. So once you have this idea, you basically use that to draw all six faces of the particular cube or cuboid that you're drawing. Okay. Now, when it comes to the animation, what I'm doing is I'm using a rotation matrix essentially. And how that works is every time the frame updates, it's going to increase the angle in the X and Z directions by 0.01. Okay. This in OpenGL, everything is in degrees. You do not need to convert to radians, which is actually a very cool thing. I'm very happy with that. Anyway, so that's what we have. And how we actually cause the rotation is using this particular function. So the rotate f function takes in the angle that you want to rotate it by, and then it looks for which a particular line or which particular vector you're trying to rotate it about. So in this particular case, you have only the x coordinate being 1 and everything else being 0, which essentially means this is the x-axis. Similarly, in this case, you have the first two coordinates being 0 and only the z coordinate being 1, which means this is the z-axis. So the rotation is essentially happening only about the um, x and the z axes. So if I show you, let me just explain what I mean by that. So once I rebuild the code by after removing the z angle rotation, you'll be able to see. Let me just give something that's not. So this is now rotating about the x-axis, right? And we all know that there's the x-axis, and this is rotation about the x-axis, and that's how the rotation matrix rotation function works. Okay. So this is the first thing. Another important thing to note is that before we actually draw our cube, we need to perform one single translation. And what is that translation? It is to move the axis into the screen. Okay, so as I've shown you in this particular figure, the axis essentially is at 0, comma 0, which right now is inside this cube. So if we do not do not do the translation as required, then we will essentially be seeing this, which makes absolutely no sense. So you basically move your axis into the screen, by which you will be able to get a better view of the whole image. Okay, so that's why what we do is we perform this particular translation. And if you remember, the minus z direction is into the screen. So I'm moving it inside by 8 points, and then I run my code, and that's how you get the desired output basically. Just to show you again what the output is, I run it, I give my length, breadth, and height, and you have a beautiful cube or cuboid, depending on your numbers, rotating about the x and z axes. Okay, so this is the first way of drawing any primitive. So if you notice these vertices that I have, right, there's also a way of actually sitting and calculating each of these vertices for say latitudes or longitudes or slices of a sphere, and then building a sphere using this particular logic. But OpenGL is like a really cool platform, and so it gives you an option of not going through all that trouble. So now let's look at the 3D primitives that OpenGL provides to us. Okay, so here you have, I've just made a list of everything. So we begin with a sphere, okay, and the spheres, like how you draw the sphere is you call that function, that's a sphere, and you give it the radius, the number of slices, and the number of stacks. Now what are slices and stacks? So you can imagine slices to be the longitudes and stacks to be the latitudes. So when you draw a sphere, you essentially draw a lot of circles in the vertical as well as the horizontal directions. So the slices are the vertical or the standing circles, and the stacks are the sleeping or the horizontal circles. And these are stacked together to form the sphere. Next, we have the cube. The cube will require just your size. Size is basically the side of the cube, and it draws that. For the cone, we have the base radius. Then you have the height, and similarly, you have the number of slices and stacks. Okay. Now, then we have a torus. A torus is basically this image that's been drawn over here. It requires an inner radius and an outer radius, as well as the number of sides and the rings. So now, while building the torus, actually, there's a mathematical formula which I will show you. I'll show you what it looks like once we run the code. and that is where the n sides and the rings comes into picture. Then we have a dodecahedron, which is a 10-sided figure. A 10-sided figure, and this particular 10-sided figure just has one, it doesn't have any parameters. It's a standard dodecahedron whose radius is root 3. We then have an octahedron, which is an 8-sided figure, and this again has no parameters and has a radius of 1. We have a tetrahedron, which is literally the half of a octahedron. A tetrahedron is something which has 4 sides, and this has a radius of root 3. Um, an icosahedron, which has 20 sides, and this figure looks really cool. And this also has a radius of 1. And finally, for some reason, OpenGL has provided us with a teapot, and you can give relative sizes. So you can have a small teapot and a large teapot, which is really fascinating. So let's look at that code. Okay, let me just add the code to this and build my project. So right now, the code that I have allows you to basically choose whichever one you want. So I'm going to start with the sphere, and there's your simple sphere. Now that sphere, obviously you can't see it much, so I'm just going to re-choose a sphere and increase its radius to about 3, and there you go. So right now you can kind of see the slices and the stacks that I mentioned. According to the program right now, they are fixed at exactly where is it, 20 slices and 20 stacks. Okay, this is just for convenience sake, and it looks cool. Now I don't need to do anything to change my, I don't need to rerun the code or anything, because that's the program that I've written. So I can quickly switch over to a cube, and I can choose the, okay, when I say radius I mean the side actually, sorry about that. But so let's say a 4 length cube, and there you have the cube. The cube is again rotating, changing colors, that's fun stuff. But yeah, that's that. Then you have the cone. So let me show you what the cone looks like. The base radius, say, is 4, and the height will be 6. And there's your cone. Now, the cone, obviously, during its rotation, will look like it's changing its shape, but it's not actually changing its shape. It's the projections that are that is going through. And again, you can see the stacks and the slices. Here again, it was given as 20 and 20, just for convenience sake. After the cone, we have the torus. So the torus will have an inner radius of 2 and an outer radius of 4. And here you have this very, very interesting figure. Now, the number of sides here is, if you can see in the um, rings that are made up of, like the rings that are inside, you can see there are literally just lines, and those are the sides that we're talking about, and the rings are the rings. So as I showed you in the function definition, we have the number of sides and the number of rings, right? So that's what these things correspond to. So you have the rings, which you can see, and the sides in between those rings. Okay, so that's the torus. We then move on to our dodecahedron, which looks beautiful. It's a 10-sided 3D figure, and if you sit and count, you can count all 10. It's fun. Then you have an octahedron. Okay, maybe I should move these a little bit closer to the screen. So let's do that quickly live in front of you. So right now the translate function that we have is sending it into the screen till -7. So let's bring that out to about -5 and rebuild the project. Um, so we have a project rebuilt, and let's start the program. I'm going to start at the dodecahedron, and there you go. That's slightly bigger. Let's check out the octahedron. Okay, let's increase the size a little bit more. So let's say -2. And am I translating it anywhere else? I don't think so. So let's just save the file and rebuild the project and view the output. So it's a 5. There you go. Beautiful. And I think I have zoomed in too much. Okay, let's fix that. Let's fix that. Let's fix that. Let's make this 3. There you go. Rebuild the project. Start debugging and dodecahedron. There you go. Beautiful. Okay, so that's your dodecahedron. And next we'll look at the octahedron, which also looks beautiful. It has 8 sides, and all of the sides are actually triangles. It's quite interesting to note. And we have our tetrahedron, which has 4 sides. And finally, we have our icosahedron, which has 20 sides. Even here, the sides are essentially triangles, which is a very cool thing. Finally, I'll show you the teapot. The teapot looks really small right now, so I'm going to increase its size to and rebuild and debug, and you have the teapot. There you go. Isn't that just beautiful? So coming to the code that I've written for this, we start in the main function, which calls the draw function, and in this, sorry, the display function. In this display function, we do the basic setup that OpenGL requires, and then we do the translation to move the axis into the screen. And for those fancy colors that you guys saw, I've chosen a random function to generate the three R, G, and B values. And based on what R, G, B values there are, the color is decided at every single frame. It's just a fun little addition to the program. We then carry out the same rotation that we saw in the previous program, the X angle and the Z angle. So about the X axis and the Z axis essentially, and we make sure that the scale is set to 1 1 and 1. We don't like, if we wanted a scaling transformation, we could use this. So in case of the dodecahedron and the tetrahedron, which do not have actual parameters for the size, we can use the scaling function. Now let's look at what the option is. So the option is basically which choice you're making. So you have the sphere, the cube, the cone, the torus, the dodecahedron, the octahedron, tetrahedron, icosahedron, and the teapot. Okay, and how we actually call this now, how OpenGL works is that it has something called the main loop. And the main loop is actually a function which you can't get out of. If you get out of the main loop, then your program ends essentially. So how the workaround for how to get an input while you're inside the main loop is to use something called a callback. And that callback is over here. So it's a get glut keyboard func. And the function is the get key function. Now let me just show you what the get key function does. You have the get key function, which has the parameters of a key, which is essentially like an interrupt when the program is running. And when anytime a key is pressed and you're on that window, this function gets called, and the key is whatever character you've pressed on your keyboard, and the X and Y positions are the positions of the mouse at that point. Okay, so now I need to convert the option that I've sent into an actual number between 1 and 9. So to do that, I essentially convert my the int value of the key minus the int of the character value of 0. So that gives me an option between 1 and 9. Okay, now as you would have noticed in this particular function calls, options 5 to 9 essentially do not actually take any parameters. So it doesn't make sense to actually have any other details inside this get key function. But if you choose any of the other things, then you have an option to input the radius, the size. Oh, here it is. I can change this. Anyway, so you can change the radius, you can change the size, you can enter the required details for the cone and the torus, and so on. So once again, all this code will be available on Pastebin for your perusal. And this is just a basic intro to OpenGL. It's very powerful, very simple, and I think we can do a lot from this. So just one last demo of sorts. So let's start the debugging window, and let me choose a sphere. You have a small little sphere there. Let me increase its radius to 5. And okay, that's a little too big. So let me reduce the radius to 3. Yep, and 2, and there you go. Okay, so there's your sphere. Similarly, you have a cube. I'm going to choose 2 again, and there's a cube. We have the cone. So with a height of 1 and this thing, and that's your cone. A torus 2 and 4. Okay, that's too big, but it looks cool. So let's see if I can resize this. Everything gets resized. That's actually another function that OpenGL has. When you reshape the window, it actually remaps all the points. So it's not like you're increasing your viewport, you're increasing the whole image size. That's very interesting. So you have the torus. Next, you have the dodecahedron. So maybe if I increase the size of this, you'll be able to see it clearer. Yeah, that's right. Okay. So you have the dodecahedron, the octahedron, the tetrahedron, the icosahedron, and of course, the teapot, the beautiful teapot. Thanks a lot for watching, and bye bye.